Good morning, everyone, and welcome to the IGLUNA project show of Team P4 V-GELM. These students from La Sapienza University in Rome are working on a virtual greenhouse experimental lunar model. The students will present their project in the next half an hour, so please submit your questions and comments to the team through the chat in YouTube. They will then have time to answer at the end all your questions after their presentation. Welcome, P4 V-GELM. Please go ahead with your project show. We look forward to it.
I'm Victoria Kirchi, the project manager of V-GELM project from Sapienza University of Rome in Italy. Our project is a virtual greenhouse experimental lunar module, and within our team we have some students from Sapienza University and from the University of Tuscia, and some experts from INEA, the National Agency for New Technologies, Energy and Sustainable Economic Development, and from and is our partner with Mars Planet. And our project is aims to develop a virtual reality simulation of a lunar greenhouse with the collaboration with ENEA that develop a module for life support and for cultivate the microgreens in extreme environments. And our project will be important for future mission and for the astronaut training process for the future space mission. Our mission is to demonstrate how virtual reality is useful for future mission, developing a virtual simulation operation in that greenhouse that we design, and compare that operation with real operation with the hardcube that is developed by ENEA. We illustrating you how VR is time and cost effective. And this is our sponsor, and our project is sponsored by K Adriatica and Manifattura Moiano that provided our financial support, by Open Grow 2, by CN Seeds, by the University of Milan that give us the tent for the real operation in ENEA's laboratories, and from Classico Milano that collaborate with the University of Milan for the tent. And Cultifutura is our sponsor, stakeholder for this IGLUNA 2020, and will be our sponsor for the next IGLUNA 2021. This is our project overview, and we started by the hardcube module that is developed by ENEA, and we design our structure design with a workshop in degree in Sapienza University, and our students based the design for 5 hardcube in this greenhouse structure that is better for the cultivation of microgreens for 6 astronauts in the base in the lunar base. Our greenhouse is on the ideal site that is located in a dark side of the moon, and we start the design of 3D model structure from the architectural design that is developed by the students from Sapienza. And after we design the 3D model for the virtual reality, we improve the model with the implementation for operation in virtual design. And now Ricardo explain to you the subsystems that are in our project.
Thanks, Victoria. As you will see, we mainly have 3 subsystems. The first and most fundamental which is the hardcube. It was developed in the ENEA laboratories, and it is a highly efficient and autonomous vertical hydroponic cultivation module fit for the production of microgreens. But what does it mean? It means that through the use of hydroponics, once set up, the hardcube does not need any further human assistance and can complete its cultivation cycle on its own, growing up healthy microgreens. As you can see, the hardcube is quite big, at 120 per 120 per 160 centimeters, and it weighs almost 130 kilos. But in 2 weeks, it can produce up to 5 kilos of microgreens. So far, many microgreens have been tested with the horde cube, as for example, the cabbage, the mustard, and the radish. Next slide, please. Next. The next subsystem is the tent in which the experiment is taking place at the moment, which has already been tested for Antarctica and is able to resist very extreme environmental conditions. While the last subsystem is, of course, the virtual reality simulator. We use the Unreal Engine to reproduce the activities in a simulation on an Oculus Quest device that you can see in the presentation. Next slide. In order to validate our simulation, we decided to make a comparison of the operational times. We will now guide you through this comparison with explanations and videos, starting with our Giulio Metelli, leader of the biological segment.
Thanks, Riccardo, and good morning, everyone. I'm Giulio Metelli, and I'm a PhD student in Plant and Animal Science at Tuscia University of Viterbo, and I'm the responsible of the biological subsystem. As we have planned to cultivate on top of Piatus Mountain, due to COVID-19 emergencies, we started our cultivation in Enea Casaccia Research Center. The tasks you can see here and in the following video presentation are necessary for the cultivation here on Earth as well as on the Moon and other planets where, although it is less, gravity is present. We aim to perform procedures as simple as possible to make the process user-friendly and easy to learn. Next Tuesday, we will collect the microgreens and expect a harvest of 2 to 5 kilograms of ready-to-eat fresh vegetables. Thank you for the attention and please enjoy the video.
Hello everybody, we are the V-GELM team for IGLUNA 2020 and here we present the field experiment for the virtual field campaign. The tent called The Egg was supplied by the Department of Physics of Milano University and Plasteco Milano. Initially, 4 members of our team placed an area rug under the tent to prevent some accidental damages. Then we used a specific pump to inflate the tent. This step required almost 20 minutes. The tent was designed for Antarctic missions, so it is capable of withstanding at very low temperatures. The tent was placed near the containment greenhouse at Enea Casaccia Research Center near Rome, and we also added 2 air conditioners to maintain a stable temperature inside the egg. During the second phase, we set up the cultivation experiment using 2 radish varieties, the daikon and the ryoja, supplied by CN Seeds. First of all, we spent almost 2 minutes to weigh the seeds in order to have 1 seed per centimeter, a total of 10,000 seeds per square meter. We are now ready for the sterilization process. At the beginning, we used a solution at 1% of sodium hypochlorite for 10 minutes, and then we rinsed the seeds 3 times in distilled water. Moreover, we treated the seeds with a solution at 1% of hydrogen peroxide for 5 minutes. We rinsed them, and at the end, we soaked the seeds for 4 hours. 2 members of our team started the assemble procedure of the earth cube inside the tent. The first component, the tank, was leveled and then it was filled with water and fertilizer supplied by Kappa Adriatica. 2 trays were placed in the earth cube and the entire process required almost 20 minutes. As substrate for the cultivation, we used green felt supplied by Manifattura Maiano. 2 pieces of green felt were cut to fit into the 2 trays and then they were sterilized. The seeds were sowed on these substrates. Radish daikon was planted in the upper tray and radish ryoja in the bottom tray. Manually, the seeds were spread homogeneously on the cultivation surfaces, almost a seed in a square centimeter. And here you can see the earth cube inside the egg after all these processes. At the end, we set up the control system by OpenGrow to monitor the cultivation progress and some parameters. Inside, the temperature is around 23 degrees, but sometimes it reaches 28 degrees. All the pumps and trays for the cultivation were supplied by hydroponica.it, and we also brought some instruments inside the tent for the growth analysis.
What you just saw concerned the real operations. Now we will see together how those activities regarding cultivation procedures were implemented in the virtual reality, starting from the seeds preparation up to the loading of the nutritive solution, the visual inspection, the seed sowing, and the substrate positioning. Let's watch it now. So, in conclusion, these are the operations reproduced in the virtual reality, and this is the comparison between their times outside and inside the virtual reality. The VR project is still in a state of alpha, but the times are clearly very similar, except for two operations that will still require some work to faithfully reproduce the complexity of the action in the virtual reality environment.
These are possible next steps for the only apply to IGLUNA 2021 is a new bachelor and master degree student involvement, the improvement of user interaction of graphics and user interface, the breakdown simulation procedures to improve the design of the 3D model, and the addition of other modules to improve the simulation for the next steps. Also, follow us on social media like Instagram, Facebook, V-GELM for the next steps. And thank you for the attention by our team.
Thank you very much. That was a really nice presentation, and with the videos, it was really nice to watch. I hope everybody enjoyed it. Our next part is the Q&A session. So I invite all of you watching to submit your questions now in the YouTube channel so so the students can have a chance to answer it. I see already some questions coming. So we have the first one saying, what is the benefit of training the procedures on VR instead of using a replicate of the equipment that would be sent to space?
I think I can take it. The use of the virtual reality allows us to be cost and time effective, which means that while the construction of a real model may require a lot of time and a lot of tries, the use of the virtual reality environment allows us to train astronauts in a virtual reality environment which needs not to be exactly faithfully reproducing what the final product will be like. Instead, we can now train astronauts in the right procedures that will stay that way in the final product. Also, it allows us to inspect the product before the actual construction, so it may help us identify eventual issues right before the actual construction.
That's very good. So you save time and perhaps even money to have this model. That's very good answer. Thank you very much. I hope that solves the question for our viewer. We have another question coming up. Do you plan to bring already chemically treated sterilized seeds to the moon, or to do the chemical treatment sterilization in situ?
Hello everyone, I'm Giulio, and I think that the possibility to surface sterilize the seeds on Earth and then on the moon could be a problem. We need to sterilize directly on the moon, because when you water the seeds, the seeds start to sprout. So you can bring with yourself seeds that are in a sleeping state during your flight.
Okay, that's very good to know. I was not aware of that. Thank you. Next question is, would it be possible for the plants in your system to get infected by bacteria or fungi? How would the astronauts deal with the food shortage if a cultivation cycle is lost?
The surface sterilization procedures stop all these problems, but if there is some problem like this during the cultivation, the system is modular, so we lost at least only one of the two trays of the cultivation. And if we see the problem coming out earlier, we can do practice to sterilize the portion of the trays that is infected. And the seeds that coming from Earth are still from plants that are free of fungi, of bacteria, and of virus. So the problem is really a small problem for this reason.
Oh, that's very good. So you have a really nice design. So you already take into account this potential risk. That's good to know. Next question is, what has been the most difficult obstacle to develop your project this year?
Is the managing and the control of all the activities to achieve the timeline duration. Yes, for the design and the develop of the 3D model and the design of architecture students for the structure design, for the structure project, is to improve this task is difficult for the time and for reach all your objective to the CDR, PDR, and all the phases of the project. Because students have their time, and it's a little bit slow for the project. But all the tasks are doing better and are done and are good, and we are satisfied by that.
Yes, I see. Yes, we do have strict deadlines and short time frames,
Yes.
but you completed that. So we are very happy to see that it worked and that you learned also a lot during the way. Thank you.
Yes.
Our next question is, how can your project be helpful here on Earth?
So our system can be used everywhere in the world, from desert to pole, south and north pole, and in small and big city, on the roof of skyscrapers, and in the basement. So our system here on Earth could be used everywhere. And I hope that the system would be used for people that have problem to produce their own foods, maybe in some big cities where the field for the cultivation of vegetables are very far from the production to the consumer.
I see. Maybe Julia, to follow up on this question, what would be the benefit with already existing systems and greenhouse from your system? What's the advantage then?
Yeah, the difference between our system and the big greenhouse are the dimension of the system. Our system could fit inside an office or in an apartment, in a house, everywhere, like where are you and where I am. So this is the great difference. It's a vertical system that where we can cultivate a lot of level and on a small surface near where you need it.
It is a good advantage. Yes, thank you. We have the next question about virtual reality. Would it be possible to use your VR simulation from a computer as it would be a video game?
Hello, I'm Walter, responsible for VR simulation. And theoretically, yes, you can compile the VR simulation for a desktop environment as it was compiled for the Oculus Quest. So theoretically, with some small modifications, you can actually compile it for desktop environment.
Good. That's good. Maybe we would like to see it in the future, so we can also try it, everyone. Thank you. We have more questions coming up. Thank you to all the viewers for submitting. The next question is, do you plan to have different solutions for different budgets or using different hardware? Actually, this is again for VR, so maybe it's you using different hardware for virtual reality.
Well, for now, there is no plan like this, but it could be possible to adapt the simulation for the hardware used. So if you use a high-end tracker and headset, you can, of course, fine-tune the simulation for using all the sensors and the precision of the headset you're using. So maybe you can also, but that requires a lot of work. You can adapt the simulation for light, for a light simulation, like for gear or smartphone VR headsets.
Okay, I see. Staying on the virtual reality topic, we have one more question coming up. Are the gravity conditions applied to the VR for liquids manipulation and so on? Or is it expected in future plans of the project?
It's a mix, because the simulation for now uses gravity and physics, because all the objects are moving because they are rigid bodies, and all the interactions are physics interactions. So yes, it's using gravity, it's using a modified scale gravity, but it's not actually replicating the real moon gravity, but it's pretty close. It's not scientifically accurate for now because it's still an alpha, but it's pretty close.
Do you envision for people also to experiment the partial gravity, perhaps, so that they are also hanging maybe from some system, so they feel only partial weight to their system, so it's not only what they see, but what they feel in their body, so to combine these two things?
Yeah, that would be definitely the ultimate experience for a simulation like this, because of course being in space could be simulated to some extent, because of course if there is low or no gravity, you can't feel it when you're trying the simulation. So there is some kind of difference between what you see and what you're feeling, and that's a big issue in virtual reality in general. So with suspension cables and stuff like that could be, of course, a big improvement in the experience itself.
I'm sure would like to try that, and I think many people also. We look forward to that development, hopefully one day soon. Last question about VR, so we don't monopolize here with the time with you. Is your VR system capable of being easily adapted to other scenarios, for example, to help train for spacewalk or manufacture activities?
Well, yes, it could be adapted and for any kind of activity. And it was in our plans to also implement some failures in the system, just to say about how it could be adapted, and to let the astronaut to deal with failures. And also, of course, if there is a need to extend the simulation to spacewalk or other external activities, it could be easily adapted.
Okay, thank you. Great job for the VR part development.
Thank you.
Maybe now going back to Julio, someone noticed from the audience that there is just very little space inside the inflatable tent. And then touching again with the VR, do you plan to use the VR simulation? Would it be also something of interest to address these issues of space? And how could you do it to integrate what is really physically there to the VR part in the tent?
For this project, we recreate a virtual reality of a moon base, but here on Earth and in Casaccia Research Center of Enea, we have the egg tent, but the use of this tent is only for the realization of the project on the Pilatus mountain and in our research center. So there is not a correlation between the two world, the real and the virtual, for this kind of activities. We have only one Earth tube, and we use the tent to thermal design, thermal maintain the thermic the temperature inside the tent. And for the virtual reality, instead we need to recreate the objects like the beaker, like the solution, like the seats, like the trays and the substrate, and all of this. Walter did it for the virtual reality.
Excellent. Thank you very much for your very complete answer. That's all the questions we have at the moment in the channel. If someone else wants to add something here from the team, just to complement and close the session on your side, would you like to say something else? We can conclude the session. Thank you, Team P4 V-GELM, for your fantastic project show. It was really complete with the presentations and the videos, giving us a perspective of the virtual developments, but also with the real things you are working on. Congratulations, and we wish you all the best for your next steps. And our next show is P5 Sample Project Show, coming up at 13 hours Central European Time. For all our viewers, please fill in the survey here in the video description below, as your answers will be very valuable for our future events. Thank you, everyone, and see you later. Bye.
Bye. Thank you.
Bye.